In this video, I'm going to be teaching you guys everything you need to know if you want to exploit proof your game in Roblox. So let's go ahead and get started. So rule number one is basically you never want to trust the client for anything important, because the client is basically where the exploiters are able to go ahead and manipulate code. So for example, I'm going to give you guys a good example real quick. The first thing I'm going to do is I'm going to go ahead and make a player's added event. And then what I'm going to do is I'm basically going to give the player an attribute of coins and set it equal to 0 for now. Okay, so now each player that joins is going to have an attribute of coins that is set to 0. So now let's say that we basically wanted to buy this sword. I'm going to show you guys the bad way to do it, and that is by trusting the client. Alright, so we basically have our buy sword button right here, and when we click it, it's going to go ahead and give us a sword if we have the right amount of coins. So let's go ahead and do buy sword dot mouse button one click connect to a function here. And let's say that instead of firing to the server to go ahead and check from the server if we have enough coins, let's say we just check it from the local script. So we say local coins is equal to local player get attribute coins. And then we can go ahead and say if coins is greater than, let's do 50, then we can go ahead and print you bought a sword. So on the surface level, this looks like code that is completely fine. But the problem with that is that when we're checking the coin that the player has from the client, we're basically checking something that can be manipulated very easily by exploiters if they wanted to. So now if you were to go ahead and play the game here, and I were to try to buy it, obviously it wouldn't work. Well, let's say I was a hacker and I go straight to my player here, and then I go to coins and I set it equal to 55, and then I go ahead and buy it. As you can see now, it says you have bought the sword, even though if we go to the server, real quick guys, if you guys have been wanting to learn how to script on Roblox, check out the first link in the description. In reality, I don't actually have that 55 coins and I only have 0. So whenever you're making big decisions like actually purchasing items in the game or any game logic or anything like that, you want to have it done in the server. So for this situation here, what we could do instead is we can go ahead and create either a remote event or a remote function. To make this easier, I'm just going to go ahead and create a remote event. And if you guys don't know what remote events are, check out my paid program, the first link in the description, where it teaches you how to become an expert Lua scripter. So let's go ahead and add a remote event into replicated storage here. And we're going to go ahead and rename this to buy sword. So let's go ahead and get this. So we'll say local buy sword remote event is equal to game get service replicated storage wait for child buy sword. And then here we're going to go ahead and delete this. And what we're going to do is simply say buy sword remote event fire server. So now I'm going to go ahead and copy this and paste it up here. And then we're going to say buy sword remote event dot on server event connect to a function with the player. And then now what we're going to do is we're going to go ahead and check from the server side how many coins this player has. And if we have enough, then we're going to go ahead and give them the sword. So what we're going to do is we're going to say local coins is equal to player attribute coins. And then we'll say if coins is greater than 50, then we can go ahead and do player set attribute coins to coins minus 50. That way we just subtract it. And then we can go ahead and print out you have bought the sword successfully. So now this is a way safer way of actually purchasing an item, because we're doing it all from the server. So if we were to go ahead and run it now, we're not able to buy it obviously. But if we go to our player and we go ahead and set our coins to 55, when we click it, as you can see, we still cannot buy it. That's because in the server, our coins are still at 0 and it's checking from the server. So now if I were to go ahead and set this to 55 from the server, and then we were to try to buy it, as you can see now, we have 5 coins because it subtracted 50, and we have bought the sword successfully. So the big lesson here, guys, is to not trust the client for anything that's important. You want to go ahead and have it go over to the server. Okay, so now I'm going to give you guys an example of how remote events can actually be abused by exploiters. And it's actually pretty interesting, so let's go ahead and get into it. So here I have something called a damage remote. It's basically a way that we're going to go ahead and damage our player. And let's say right here that this is a piece of code that an exploiter put into the console. So exploiters are able to actually do this if they have a remote event. They're able to go ahead and call things like, for example, damage remote. And then instead of having an actual number here, they just put like 99 to go ahead and kill the other player really fast. So this is very common. And the way we can go ahead and combat this is we basically have to add a few checks when we go ahead and pick up the remote event. So here, obviously, we get 3 arguments, which is the player, the target, and how much damage they're going to take. So for this example, I just passed through myself. So basically the target and myself are technically the same thing, but it's okay for this example. So let's say that 9 was passed through. Obviously, this is not a valid thing, and we know that this is an exploiter that's trying to go ahead and kill the target. So what we do here is we do something called type checking first, and we basically reject any arguments that aren't valid. So basically what we do here is we check the type of target, and if it's not equal to instance or the target is not a player, then we just go ahead and return and nothing else goes ahead and runs. So we want to make sure that what we're getting is actually valid. And then we say if type damage does not equal to number, then we're going to return, because obviously the damage has to be a number. So now that we have these checks out of the way and we make sure that first of all, the arguments are actually valid for what we want here, then what we do here is we actually clamp the damage to a normal range. So if our weapon's max damage is 25, we're going to go ahead and cap it there. So we set the damage equal to math.clamp damage 0, 25. So basically what this does is if this damage is anything over 25, it's going to go ahead and automatically go to 25. And if it's anything below 0, it's going to go ahead and set it equal to 0. And then if the damage number is between it, then it's just going to go ahead and return the normal damage number. So this way we're basically ensuring that no matter what they pass through, it does have a cap of 25. So the next thing we do here is we verify the target is actually alive. So whatever they pass through here, we need to make sure it's actually a character. So we say local target character is equal to target.character. And then we say if this does not exist, or if the humanoid does not exist, then we're going to go ahead and return because, well, there's nothing to really do here. Then what we do here is on the server side, we basically verify that the attacker is close enough to hit. So we basically are checking to see, okay, is the attacker actually next to this person? So we say local attacker character is equal to player.character. And then we go ahead and look for the character and then the human root part. And if it doesn't exist, then we just return. And then here we just simply get the distance between the attacker character and the target character. And then we say if the distance is greater than 15, then we know that they're not in the correct range and we return. And then after all these checks is basically when we go ahead and have the target character take some damage here. So even though this does seem like a lot of checking, this is basically what you have to do if you want to ensure that your game is safe from exploiters. Because whenever you're accepting arguments in a remote event, you have to understand that exploiters are actually able to manipulate this. So they're able to fire this remote event as many times as they want with whatever they decide to put in the arguments. So if you ever are accepting arguments in a remote event, you have to go ahead and double check everything on the server to make sure everything looks proper. Alright guys, so lesson 3 is basically to never store sensitive data on the client. And I basically gave you guys an example already in the server script where I went ahead and set the player's attribute of coins to 0. And I did this in the server because, well, the coins is like a pretty sensitive data type, since we're probably going to be using this to go ahead and buy things in our game and things like that. So if I were to go ahead and cut this and basically put it in a local script, and I were to do local player :set attribute coins to 0 whenever the local player joined, the problem is that first of all, on the client, it appears as 0, but on the server, if we go to our player here, it doesn't even exist because it was created on the client. So obviously this is pretty bad. So whenever we are dealing with sensitive data, we want to go ahead and deal with it in the server side. So never have any sensitive data on the client, always have it in the script. And if we are checking something like the coins or anything that's sensitive that the exploiters can change, we want to check it from a server script. Alright guys, so the fourth thing we're going to be talking about is something called rate limiting. And basically what this is it's checking whenever we fire a remote event if the exploiter is basically spamming it, because exploiters do like to spam this. And the problem is that when you spam something from the local side and it spams to a server script, that server script basically gets all messed up because it keeps going to this remote event and it's being spammed, and it's just not good for your game. So what I did here, guys, as you can see, I basically implemented a system that goes ahead and first of all uses tick, which is basically just Roblox's way of using time. So basically it gives it a time. So we say now is equal to this time, and then we just get the player user ID. And then what we do here is we basically make a table called last fired. And then if we say if last fired and then the key as user ID exists, and now minus last fired with a key of user ID, this is basically going to go ahead and give us the last time that it was fired. So if the time of now minus the last time it was fired is less than the cooldown of 0.5 seconds, so half a second, then we're just going to return, because that means that it was basically fired too fast, and we don't know if this is an exploiter. Then after this, what we can go ahead and do is we just simply set in the key of the player user ID of last fired equal to now. And then after this, we would process the attack normally. So obviously I'm not going to write out the code now, but it would just be whatever code that is. And then whenever the player were to leave, we would just go ahead and set this last fired key equal to nil. So that way it goes ahead and frees up the space that was inside of here. So yeah, guys, it's a pretty simple concept for rate limiting. It's basically kind of like a debounce, but on a remote event, just to ensure that we're not spamming this remote event, because that would not be good for our game. Alright guys, so now for this next part, we're basically going to be talking about how we can detect if someone has like super speed or if they're moving at an abnormal rate. So guys, what we have here now inside of the server script basically looks like a lot of code, but don't worry guys, I'm going to go over it bit by bit. So the main thing that we're doing here is basically every second we're going to go ahead and check distance between the human or root part's position 1 second ago and the position of it right now. And then we just calculate the speed by simply just doing some simple math. This is delta time, which is just tick, minus the data.time, which is the time from the last second. And then after we get the speed, we basically say if the speed is greater than the max speed that we have up here, which is 80, then we're going to go ahead and warn the player that it's moving at pretty fast speed, and then we kick the player. And another change that I added just now is basically the problem with this is if we ever teleport the player in the game. So for example, let's say the player was right here and then we had to teleport him over here for something. This would technically go off because the distance between the last position to the now position is so great. So what we do now is we basically have a table called teleport flags, and it basically tracks legitimate teleports. So if we were to actually teleport our player, we would do it with this function here. And what this does is it basically goes ahead and tells us that this player had a safe teleport. And then we just go ahead and actually teleport the player to wherever we want. So now inside of here, if the speed is greater than the max speed, we first check if the teleport flags player.userid is equal to true. And if it is, then that means that this was an actual teleport. And then we go ahead and reset it to nil. But if it's not, so if this is equal to false, then we didn't have any sort of teleport happen. So we're just going to go ahead and warn that someone was moving at a very fast speed. And then we're going to go ahead and do player:kick. Go ahead and kick them from our game. So now, if I were to go ahead and set my speed here to something like 100 or 200, and then I go ahead and speed around, it should go ahead and kick me. So it did go ahead and kick me, guys, but since we're in studio, it's not showing that. So it basically said Windlicker is moving at 170 studs per second. So yeah, guys, this is basically how we're able to detect if someone is basically trying to speed through the map or anything like that, and it'll go ahead and kick them. And yeah, guys, I basically just walked you guys through a few ways you can go ahead and exploit proof your game. I'm sure there's going to be other ways that you can, but this is just a good place to go ahead and start and make sure that you are implementing these things into all of your game to ensure that your players are obviously going to have the best experience. But other than that, guys, I hope this video helped you, and I'll see you in the next video.